This is the week 10 of the Java lessons, and today we'll just be going over inheritance. If you have any questions about like the slides or anything else, feel free to just jump in and ask or put your question in chat. And yep, let's get to it. So for today, we're just going to be going over a brief introduction and review about classes. I'll also be going over like class diagrams, how to read them. And then finally, we're going to be talking about subclasses or like inheritance and how to make subclasses. So again, we had, for the past 2 weeks, we've been talking a little bit about classes. So just remember that like classes are kind of blueprints to objects. They can have states and properties. So like, for example, a dog class can hold information like the color or the name of the dog. They can also have behaviors or methods. So a dog can bark or it can run. Also, I remember last lesson, we were talking about, I talked about making a general list of terminology that can be like pretty confusing, or like terms that are the same and the ones that are different. So here's that link. This is basically a general list of different kinds of terms that you'll often see like people use in like programming. Some are Java specific, some aren't Java specific. So this is just like grouping all these terms together and then giving you basic definitions and examples of that. So if you're ever confused about like what I'm talking about, feel free to ask in chat or like interrupt me. Or you can also try like refer to this as a little bit of a dictionary. And also if you're confused about other terms that aren't on this list, just give me a heads up and I'll like add to this document. All right, so we talked about classes for the past 2 weeks, and now we're just gonna start going into more conceptual things. So the first one is like Java is an object-oriented programming language. So, and as an object-oriented language, it has 4 major principles. These 4 are encapsulation, abstraction, inheritance, and polymorphism. You don't have to worry about these 3. So like encapsulation, abstraction, and polymorphism, don't worry about them. If you're curious about what they are, you can always like look them up in your own free time. The one we're going to be focusing on today is inheritance. So inheritance is sort of, it's just like inheritance in the real world. It's a class can inherit like the properties and behaviors of a parent class. And usually when we're talking about inheritance, or like a real world example is like you can inherit like looks and behaviors from your parent, or like yeah, or stuff like that. So basically that's what inheritance also is in object-oriented programming. So a parent class or a child class can inherit a behavior or a state from its parent class. And when we're talking about like making subclasses, we think of it as having an is-a relationship. So let's say we have a class called animal, and it has a subclass called fish. So we think about it as fish is an animal. So it gets all the behaviors and the states and the properties of the animal parent class. This is a little different from when we're talking about things like class variables. So an animal can have a age or a gender, but that's different from having a subclass. So like a fish is an animal and an animal can have an age. So basically that's how subclasses are different from, let's say like just having like a class variable or a field. Yeah, so basically for class diagrams, obviously this isn't actual like Java code, but these are basically, each box is a visual representation of like a class and what this class has. So yeah, like Dana was saying, the top portion of this box, these are the attributes or the fields of the class. And then this bottom half is the methods this class can have. So basically, like the box itself is the class. The top part is the information it can hold. And the bottom part is what it can do. So what methods does it have? And now you'll notice that like we have these 3 other classes at the bottom, and they all have arrows pointing to animal. So what these arrows mean is that these classes at the bottom are inheriting from animal. So basically, fish can have its own properties and its own methods, but also inherits from animal. So inherit these behaviors and this information from animal. So, and the reason the arrow is pointed up is because inheritance is sort of a one-way street. So fish can access like all the information and methods from animal, but animal can't access the information. Yeah, so don't worry too much about the pluses and minus. I think it's a little nuanced, like syntax stuff, but right now we're just focusing on like in general what class diagrams are, and more importantly, like what these arrows mean. So the reason like I'm showing you guys these class diagrams is that like for when you're like doing programming, sometimes like you're focused so much on syntax that that you miss like the conceptual ideas. So it's important to separate like the syntax, so like how to do something in a certain language, from like the general concept. So especially when you're like writing inheritance, and eventually like you'll write programs that do more than just like inherit from like having a class inherits from another class. It's important to keep like the concept of classes separate from like the actual code itself. That way, like you'll think more about the class design and not about like, oh, like how, like, or I guess like in another way to put it is like that you're focusing on the big picture and not like being stuck on tiny details. All right, so now that we've talked about just like inheritance on a conceptual level, now we'll get to actually like talking about how to implement inheritance in Java. So first off, in order to implement a subclass, you'll basically use the extends keyword. So in like when you declare a class, instead of having like just class X, it'll be having class child extends parent class, and then like the class definition at the bottom. Again, like subclasses inherit methods and fields from their parent class. And then in order to refer to the parent class, you'll use the super keyword. And inside the constructor, you should always use like super parentheses in the constructor. What this does is it basically calls the parent class constructor first, so that initializes all of like the parent methods and fields. And then in Java, you can only inherit one class. So this is more Java specific, but like for Java, you can only have one parent class. So you can't inherit from a bunch of different parents. So when we look at this, or I guess like we can also look at this diagram. So like this is just another class example of a class diagram. This one's way more simple, like way simpler than the one we saw earlier. You can, on your own like free time, I would recommend you sort of try and practice implementing this diagram in Java. So next, ignore the demo easy link. So I'm just gonna actually just like give you guys some live code of like creating a custom class and showing you guys like how inheritance works. So first, let's not do this. Okay, I'm just gonna go back. And then I'm gonna actually implement, let's see, I'm gonna implement the car class, and then we'll implement a truck class that will inherit from the car class. So I'm just going to create a new file to make everything more neat. So first, I'm just going to have a quick class car. And inside this car class, if I go back into the class diagram, basically it has three fields. So first one is color, horsepower, and number of seats. So I'm just going to instantiate three, let's say, or they have to be public fields for me to show you how inheritance works. Three public attributes, so color, horsepower, and num seats. So public string color, public int horsepower, and public int num seats. And then let's actually add, let's say, one class method. So I want to have a method drive. Just to show you guys like how inheritance works with methods too. So first I'm gonna create the car constructor. And again, like when you create an instructor or a constructor, you want to pass in all the values to instantiate these three class fields. So I want to pass in a string, let's say C, int h, and then int n. So this dot color equals C, this dot horsepower equals h, and then this dot num seats equals n. And then for this method drive, public, let's say void drive. So this is a public instance method that returns nothing called drive. And then for drive, let's just print out that int or system.out.println driving. Let's just say it prints out driving. So now I've created a class. Sweet. So I basically just declared these three variables, made a constructor, and then made a quick public method. So next, let's get to a subclass. So the subclass will be truck.java. And for this subclass, I wanted to inherit all of the fields from car, and then add an extra class or add an extra field called trailer. So for class truck, in order to declare a class as a subclass of another class, I'm going to have to use the extends keyword. So this will extend the from the car class. So in other words, it will inherit all the values from the car class. So when I'm in my field, or when I'm in the class, basically now truck has access to all of these three fields, and also this public method. And then now I want to add on another class field, so truck or trailer. And let's make it a public. Let's say it's a integer trailer. And then I'm going to create the constructor. So inside a constructor for a subclass, you should always call super first. And notice how this kind of just looks like another constructor. And this is basically what it is. It calls a constructor for the parent class. So when I'm calling the constructor for a truck class, the first thing Java will do is it'll see this super line and it'll actually call this car constructor. So it can basically create like it can basically instantiate all of the values for the car parent class. So because of that, we should also pass in like all the parameters that are required in the car constructor. So we'll have to pass in a string and 2 integers so that we can basically instantiate all the values in this. Or actually, no, I think I'm doing this wrong, sorry. So you'll just have to call this super to create instance, and you can actually just like, now that you've created an instance of super, you can basically access these 3 values. So this dot color equals, let's say all trucks are red for now. And then this dot horsepower. I'm actually not too familiar with cars, so let's just say 18. And then this dot num seats. So basically, after you sort of create instance using like this super line, you can actually access all the 3 values in car just by using this dot whatever. And then finally, actually need to create a parameter over here to declare the value of trailer. So this dot trailer equals T. All right, and then so in this main method, we can have, let's instantiate a car first. Car C equals new car blue 4 and 4. So this will create a car with the color blue, 4 horsepower, and then 4 seats. So we can do like a system out that print line C dot num seats. And then now we can also create a truck T and then do something like system.out.print line T.num seats. And let's see if this runs. Okay. All right, my bad. So super actually does call the constructor. Yeah, so sorry about that, guys. So basically, this super is just going to call the constructor of the super class, so the parent class. And then as you can see, like over here, truck can basically inherit the fields of the car class. And then it can also access like whatever information the car has. Let me actually run this updated. So in this main method, I first created like a car object that has the color blue, 4 horsepower, and 4 seats. And then I just printed out the number of seats for the car. Let me actually add like car number of seats for C. So over here, I just print out the number of seats for the car C. And then over here, or I've instantiated a truck object that takes in 4, which is the number of trailers. And then remember that inside of truck, we've already passed in parameters for the parent class. So all trucks will be red, have 18 horsepower and 8 seats. And the only thing that will be different between them is the number of trailers. So I've just instantiated a new truck that's 4 trailers. And then over here, I'm gonna copy this over first. And then I'm just gonna print out the number of seats for T. And what this will do is it should print out 18, or sorry, 8, because 8 is the number of seats for all trucks. And then finally, what I do is I'll actually access a method in T's parent class. So inside the car class. So for car.java, I've created a public void method called drive. And all that prints out is driving. And I'm just showing in this main method that even inside, like, even for a subclass, I can access the parent class's public methods. So when you run it, it'll just print out number of seats for C is 4, number of seats for T is 8, and then driving. And then someone asked in chat, why can't we pass these 3 values as arguments in the super method? Yeah, I made a mistake in that part. So for the super method, this is the constructor for the parent class. So we'll have to pass in like 3 values. Yeah, sorry about that. Anything else? So just to show you guys some more, when I'm creating like, or I guess like I could explain what, like why Java calls extends. So basically for like, especially for Java, when you're creating like a subclass, sort of think about it as you're building on top of the parent class. So parent class is kind of like this base class, and then you're sort of adding new fields and methods to it. So that's why it's called like truck extends car, because truck is extending the amount of information and behaviors that the car can do. So that's also why, like, for your parent classes can't access the fields and methods of their child class, because the child class is building on top of the parent class. The parent class doesn't have the information that the child class has. It's yeah, I would like, you can read up more about like JVM and like different Java compilers, but basically what happens is like the first thing you have to do for a Java program is to actually compile it. Replit actually sort of hides that away from you, because when you click run, it'll actually compile first and then run. But when you're working on Java, like working a Java program on your own, if you're not using like an IDE like Eclipse or VS Code, you actually have to compile the Java program yourself. And the compiler will just like, it'll read all the syntax. First it'll do like syntax checking. Then it'll look at your dependencies. So it'll see like, oh, I have something called car, and I have something called truck, and these are classes. So do I have this class defined inside of like these other files, in these other .java files? And then finally, it'll do other optimization stuff. But after that, like, you'll have to actually execute the run command. And then that's when like it'll just execute the main function like line by line.
So when it sees the command on line 14, t.drive, it goes, it refers to truck.java, or it refers to which one? Truck or car.java? What does it refer to print out the word driving period?
So basically, it'll refer to, first it'll refer to truck.java, and it'll see like, oh, truck is a subclass of car. So truck extends car. So then it'll refer to car.java, or the car class, and then see that has a definition for drive. So that's basically like how it be in a different way. Like, I think like maybe it's sort of the syntax that might be confusing for you. So let's actually ignore the Java syntax, and just draw like a little class diagram of like, or I guess not even a class diagram, but sort of a visual representation, a different way of like representing subclasses and classes. So let's say I have this class. This isn't a class diagram, by the way. So this is just like more like a drawing of a class. So let's say I have this class called car, and inside of car has like a bunch of different information. So like, let's say for now, this car just has number of seats. And again, like this isn't any sort of Java code. So this is just going to be a different way of seeing classes and subclasses. And let's say it also has like an action called drive. So this is basically my visual representation of what a car is. And next we basically want to subclass car out. So we want to make a subclass called truck. So what the subclass does is it actually just builds on top of, I'm just gonna say it just builds off of car. So this is, let's make this green, and then we'll call this truck. So for truck, we add on a little bit more information. So we want to add on information about the number of trailers. And this is an integer. So visually, like this entire thing, like both the square and the triangle, is what the truck is. So it's a car, but it's a car with a little bit of extra information about it. So that's why over here for line 14, we can access this drive method, because like in the end, a car or a truck is a car. So it can also have this method called drive. Okay, I think I understand what's confusing you. I think you're having some confusion about like scoping. So let's change this this variable name, because I think like you're being confused about we have like inside of the truck class we have a parameter called t, but we also have like another like variable over here called t, and it's a little confusing. So I can like I can just like go over a little bit about like scoping in Java. So basically for Java, like you can have multiple variables in your program that have the same name, but like as long as they're not in the same scope, as long as they don't exist at the same time, there's not going to be a problem. So basically over here, we have like, think of like these parameter names or these parameter variable names as like, they're more like temporary variables. So these these parameter like variables exist in a local scope. And what I mean by that is they only exist inside of this method. So outside this method, t technically does not exist and you cannot access it. So that's why over here, I can have another variable that's completely separate from the t in truck.java and still call it t.
Okay.
Yeah.
So if you run this the way it is now, will it still work properly?
Yep. So yeah, that's why like over here, I can have this variable be called t, and it can be a totally like separate thing from the t inside of here. Because over here, the variable named t only exists inside of this method. Outside of it, like Java won't see it basically.
Okay, thank you.
Yeah, no problem. Any other questions? Sweet. So let's see. We have like 9 minutes left. So if you guys have like, I guess I can go over the quiz questions really quickly. But if you guys have any other questions, like I'm also free to answer them right now. Sweet. So let's go over the quiz questions then. So question number 1, in Java, can a subclass inherit from more than one class? Yeah, so the answer is false. In other languages, you can inherit from multiple classes, but in Java, it's strictly only one class. All right, question 2. A subclass has a blank relationship with their parent class. So is it A is a type of, B is a, C implements, and then D all of the above. So B is the correct answer. A subclass is a parent class. So again, like a subclass basically is the base class plus a little bit of more information and behaviors. For C, like implements is also like a Java keyword for something called interfaces, and that deals more with polymorphism. If you guys are interested in more like complex code, like Java coding, you can also check out interfaces. All right, so what keyword would you use to refer to a subclass's parent class? Is it A, parent, B, super, C, root, and D, supra? Yep, so the superclass, like the way you access a superclass or a parent class is through the super keyword. That's why I'm also like calling it superclass, like, and mixing them up together. All right, so number 4 is in a class diagram, what marks inheritance? So like what represents inheritance? All right, so we have 2 answers for B. That's correct. I feel like maybe when we made this quiz, we should have mixed all of these answers together. I feel like all the answers are B. But yeah, so the arrow must point away from the parent class, or towards the parent class and away from the child, because that sort of shows the one-way street of inheritance. All right, so number 5, which of the following is correct if otter is a subclass of animal? Yep, so in order to show that, like when you're declaring a class, for a subclass, you have to have class child class extends parent class. And then finally, in this diagram, fish is a subclass of animal. So which is not a field animal can act? Yep. So again, like a parent class can't access the fields of a child class. So it's only that a subclass can access the field of a parent class. All right, so that's basically it for